Today I'm going to show you guys the proof of this famous equality, e to the imaginary theta equal to I times sine theta plus cosine theta. This is one of the most important equations in mathematics, and you probably will incur this type of equality in, as well as its application in differential calculus, in differential equation, linear algebra, and finding the uniqueness of solutions. So if we go about, there's many ways of going about proving this equality, but one of the most direct as well as very practical way of using Taylor series would be applying the Maclaurin series to the function sine theta, cosine theta, and e to the x. So let's go ahead and try our first approach. Our first approach would be, so you have a Maclaurin series. You have sine theta is equal to sigma to infinity n equal to 1 minus 1n times x 2n plus 1 over 2n plus 1 factorial. Okay, you can write that out, you can expand that, and the first one, put it in, sorry, this is 0. 0 you put it in, that's 1, and 0 put in there, that's x. Right? So next, 1 minus 1 to the n, that's minus x to the cube. 1 put in here, 2 plus 1, that's 3, so 3 factorial, plus 0, 1, 0, 1, and 2. Minus 1 to the 2, that's 1. 2n plus 1, n is 2, that x equal to 5. X to the 5th, 2n plus 1, 5th factorial. And it goes on and on. Okay? So now we have sine theta, so let's look at cosine theta. What happened to cosine theta? Cosine theta, the Maclaurin series for cosine theta is n equals to 0 to infinity, minus 1 to the nth, x 2n over 2n factorial. So you go ahead and expand that, just like this one, 1, 0, 1, and 2. Here the same thing, 1 you put it in here, that will be 1. 1 put in there, that's minus x squared over 2 factorial. Okay, plus x to the 4th factorial, and you go ahead, go on and on. X to the 6 factorial. Okay. Now there's some interesting sort of resemblance between this function and the function of e to the theta. You can have e to the theta, e to the x, represented by a Maclaurin series, would be sigma n equal to 0 to sigma to infinity x n over n factorial. So you have, you can expand it, and what is it going to equal to? X 0, that's 1. Okay, 1 factorial, 0 factorial, that's just 1. So 1 over 1, that's just 1. So 0, you have 0, n equals 0, n equal to 1, that will be x to the 1 over 1 factorial, that's x. N equal to 2, x squared over 2 factorial. N equal to 3, x cubed over 3 factorial. Okay. N equal to 4th, we keep doing that, and we would have a series, something like this. Okay, so so let's have a look at this. Here we have sine theta. Well, this is theta, but you can think of x as just theta. I wrote here theta because I want to make a connection to you guys. Here it could have been x, but I wrote x here, but it could have been theta. So you can write, instead of x, you can just write theta. and x here, you can think of it as theta. So let's fix that and say that's theta. Okay. Just make a connection there. Theta cubed, theta to the 5th. Same thing here. We have cosine theta. X is just a variable. As well as theta. You can put think of x just theta. So let's fix that. We have theta cubed, theta squared, and here you have theta to the 4th, and here you have theta to the 6th. Okay? Alright. Here, because of this function, e to the x, as we said, that x can be anything. X can be just a variable, right? So we can apply x equal to I theta, imaginary theta. So let's just put it in and see what happened. So here we have e to the x. We can put in I theta. Okay? So go ahead and apply it to that whole series. So what do we have here? We have I theta. Okay? I theta squared. I squared is -1, right? We know this, right? I squared equal to -1. So I theta squared will be minus theta squared. So we can go ahead and say minus theta squared. What about x cubed? You put I theta into x. What is that going to be? So you have, you know that I cube, right? I cube is I squared times I. I squared is -1, so -1 I theta cubed. Okay, so minus I theta cubed. Alright? X to the 4th. So what do we do about x to the 4th? I theta to the 4th, that's I squared times I squared. So I squared is -1. -1 times -1, that's 1. So you have here that is theta 4th. Okay. What about 5th? 5th is I 4th times I. So I 4th times I 4th, we know that it's just 1, and I, so we have I cubed, I theta to the 5th. I theta to the 5th. Alright? X to the 6th. So I theta to the 6th. I to the 6th, that's 3 times, or you can say I square to the cube. And you know I square is -1. So -1 to the cube, that's -1. So minus, here you have minus theta to the 6th. Okay? And so on. So what do we have here? Alright? We can look back at sine theta. Alright? And see what happened. If we times sine theta by I, you see, you times sine theta. Let me change the color here. So if you times both sides by I, okay, then I theta, you'll be having I theta I, or I theta times I cube plus I to the theta 5th. Okay? And see what happened here. You have I theta, you have minus I cubed over 3 factorial, you have I theta to the 5th over 5 factorial. Okay? And now we look at cosine theta. See, you have 1, you have minus theta squared 2 factorial here, plus theta 4 over 4 factorial here, and here. So it will sum it up. Therefore, the sum of these two functions, cosine theta plus I sine theta, would be equal to this, I theta. So we say QED. Okay? This is a very direct way using Maclaurin series. It's a special case of Taylor series where you can apply that into each individual component and do them by comparing method, and therefore you will have an inequality. Next video I will show you guys how to approach this inequality and how to attempt to prove that with using symbol calculus method using derivation. Thank you very much.